Welcome everyone. Myself Riya from Sri Venkateshwara College of Engineering from CSE Data Science Department. Today I'll be giving a presentation on the topic packet switching from the subject computer networks. So first, let's understand what does switching means. Switching just simply means that it decides upon the best route for data transmission, as there can be multiple paths from the sender to receiver. It is used to connect the systems for making one-to-one connections. What are the various switching techniques? Switching techniques is broadly categorized into circuit switching, message switching, and packet switching. Packet switching is further subdivided into datagram approach and virtual circuit approach. In this presentation, we'll be just dealing upon the topic of packet switching. What is packet switching? Packet switching in computer networks is just a simple method of transferring data to a network in the form of packets. It is used to transfer the file fast and in an efficient manner, and it minimizes the transmission latency. Here, the term transmission latency means the amount of time it takes the data to move from the source to destination. The data is broken into small parts of variable length, which is known as the packet. At the destination, all the small parts or the packets are reassembled belonging to the same file. Packet switching uses a store and forward technique. It just simply means while forwarding the packet at each hop, first it stores the packets and then forwards. This technique is very beneficial because packets might get discarded at any hop for some reason. More than one path is possible between a pair of sources and destinations. Each packet contains a source and destination address, which they independently travel through the network. In other words, packets belonging to the same file may or may not travel to the same path. If there is a congestion at some path, packets are allowed to choose different path possible over an existing network. As we know, in packet switching, the data is divided into small packets, which allow for the faster movement of data. Here, each packet contains two parts, which is a header and a payload. The header on each packet contains the information which needs to be transmitted. So next, we'll be dealing with types of delays in packet switching. First is transmission delay. It is the time required by the spent station to transmit data to the link. The next type of delay is propagation delay, the time of data propagation through the link. The third type of delay is queuing delay, the time spent by the packet at the destination's queue. The last type of delay is processing delay. It is the processing time for data at the destination. So next, let's deal with types of packet switching. There are two approaches to packet switching. First is datagram packet switching. In this technology, it is a type of technology in which packet is known as a datagram. It is considered as an independent entity, and each packet contains the information about the destination, and the switch uses this information to forward the packet to the correct destination. Further, the packets are reassembled at the receiving end in the correct order. This in datagram packet switching, the path is not fixed. Intermediate node take the routing decisions to forward the packets. Datagram packet switching is also known as connectionless switching. The second type of packet switching is virtual circuit switching, which is also known as connection-oriented switching. In the case of virtual circuit switching, a pre-planned route is established before the message are to be sent. A call request and call accept packets are used to establish the connection between the sender and receiver. In this case, the path is fixed for the duration of a logical connection. So now let's briefly look into the topic of virtual circuit. Before starting the transmission, it establishes a logical path or virtual connection using a signaling protocol, which is between the sender and receiver, and all packets belonging to this flow will follow this predefined route. Virtual circuit ID is provided by switches or routers to uniquely identify the virtual connection. The data is further divided into small units, and all these small units are appended with the help of a sequence number. Packets arrive in order at the destination. Overall, the three phases takes place here. That is a setup, the data transfer, and the teardown phase. So all addresses All address information is only transferred during the setup phase. Once the route to a destination is discovered, the entry is added to the switching table of each intermediate node. During data transfer, the packet header, or also known as local header, may contain information such as the length, the timestamp, or the sequence number. Connection oriented switching is very useful in switched WAN. Some popular protocols which use a virtual circuit switching approach are frame delay, ATM, etc., etc., or MPLS, which is multiple protocol label switching. So let's now look into the connectionless packet switching, which is known as datagram approach. Unlike connection-oriented packet switching, in connectionless packet switching, each packet contains all necessary addressing information, such as the source address, the destination address, the port number, etc. Packets belonging to one flow may take different routes because routing decisions are made dynamically. So the packets that arrived at the destination might be out of order. It has no connection setup and tear down phase like virtual circuits. Packet delivery is not guaranteed in connectionless packet switching. So reliable delivery must be provided by end system using additional protocols. So let's look into the difference between datagram approach and virtual circuit approach. Datagram approach, the node takes routing decision to forward the packets. Here, the node does not take any routing decisions. Congestion cannot occur as all the packets travel in different direction. Here, congestion can occur when the node is busy and it does not allow other packets to pass through. It is more efficient in terms of bandwidth, and there is no concept of reserving a circuit. As we have already dealt with transmission latency, packet switching helps in minimizing them. Packet switching, they are more reliable as a destination can detect if there is any missing packet. It is more fault tolerant because packets may follow a different path in case any link is down, unlike circuit switching. It is more cost effective and comparatively cheaper to implement. So now let's understand the disadvantages of packet switching. Packet switching does not give packets in order, whereas circuit switching does. Since the packets are unordered, we need to provide a sequence number to understand if there is a packet missing or not. Complexity is more at each end because of the facility to follow multiple paths. Transmission delay is more because of rerouting, and packet switching is beneficial only for small messages, but for bursty data or large messages, it is not reliable. That's all with my presentation. Do like, share, and subscribe.